Okay, here in this session here, I wanted to kind of go over this idea of daily specific growth rate. One of the more important mathematical operations we need to do as fish culturists on a regular basis, actually. And the I thought I'd do this as a little video kind of a thing because I have such a heck of a time describing this on just in on a PowerPoint. Just trying to talk my way through it. So I thought I could present the information here and kind of go through a couple calculations with you. So the premise here is that for daily specific growth rate, really what we're trying to monitor is the rate of growth. Okay, it's not necessarily how much they grew, but how much they grew on average per day over a given period of time. Okay, so a good example of that, kind of a classic for me anyway. If you're raising chum salmon or pink salmon, they're on kind of a fast track for growth. It was sort of like race horses because you're putting them out. Typically in Alaska, we're putting these fish into seawater from incubators, directly from incubators to seawater. February, March, something like that. Totally depends on how well they or what the water temperatures were during incubation over the winter, and so we're putting them out there, and it's absolutely imperative that we're only going to have them for maybe 2 months. I'd say probably 2 3 months at most. So we have a certain maybe we have a target weight we want them to hit, or we want them to grow as fast as possible. But we have to know, we have to have something to measure how quickly they're growing, if they're on track, are they ahead of schedule, are they behind schedule, am I feeding them enough, not enough. And so the way we measure this is what's called daily specific growth rate. And the premise is basically you take what this slide says, you need the number of days in the sample period. So for instance, today is I'm recording this on January 20th. I'm going to write these things down for myself. And what I used to do is I would sample them every week. Okay, so let's just say on the 13th I also took a sample. All right, so today I've got this fresh sample, and for this instance, for the sake of this formula here, it'd be W2 is your most recent weight, whereas W1 is the one before it. Okay, if that just makes sense. Just the general terms, of course, we plugged in here. So my W2 is January 20th, or today, and my W1 is the 13th of January. Okay, so I had 7 days in that rearing period. Okay, I'm kind of writing this down for myself. And then of course, this is just an example. So sometimes, like fish are growing more slowly, and it's over a long term. You're probably not going to weigh them every week. This is more if you're trying to hit a certain goal, or something like pinks and chums. You have them for such a short period of time, you have to stay on them. And also for pinks and chums, you're talking about huge amounts of feed usually, because you're talking about huge amounts of fish. Okay, so something for like Chinook, coho, sockeye, which you have for a long time as smolts in the wintertime, they're probably not going to grow much. And so I'd go for more like a once a month kind of a deal there. Certainly can do it more if you'd want. Anyway, the idea of daily specific growth rate is to monitor the rate of growth. Okay, and so you kind of need just a few things really to do this. You need to know the number of days in the sample period. So if today was your sample day, when was your previous day? Subtract today minus from the previous date, and you get X number of days. Okay, you need to know the weight of the fish on when your sample period started, way back whenever that was, and then you need the weight of the fish on the most recent day, whenever that is. Okay, and of course you can do all this stuff in retrospect as well. You can go back and back calculate, but and I'll also say this, that it's important for you to know this. I used to use this all the time as a hatchery manager. I could do these things so quickly, but these days mostly it's a formula punched into a spreadsheet, and the spreadsheet will do all that for you. But it's kind of, I think it's good to be able to just grab a calculator these days if you have an iPhone, or just even a actually I think even regular cell phones have pretty good calculators in them. You could do it right on the spot, and I've done that. So good to know how it works, I think. So I kind of want to work through a couple of examples for you. Okay, so you got these three pieces of data that you have to have: your most recent weight, your older weight and how many days between those two periods. And then the final tool that you need is a decent calculator, okay, like this one. And this is the one off of Windows. And I've got it pulled up here, so I'll pull this one up. Okay, so this is a calculator I find under just Windows 7, I think we have now. It doesn't really matter necessarily where you get these things from. They have them on the internet that you can pull up as well, and you probably have one on your phone, whether you know it or not. And so when I pulled this up, this calculator function, the first thing I get is this kind of standard calculator, which has really basic stuff on it. But that's not what I want. I need a scientific calculator. And I want to find this function right here. It's called a natural log. I don't want to go into what natural logs are or why. I don't want to do that. That's not really a great teaching method, but this isn't a math class. Okay, so just trust me on this. So the natural log function is something you need. Okay, so now that I have those things, I'm going to pick out some weights. And I wrote down a few the other day. Let me find those here. And were pretty good examples. Okay, so let's come up with some times here. So I came up with a deal. Let's use today's date. So my today's date is January 20th. Okay, and I'm writing these things down. And today I did some weights on some chum salmon, and I come up with 1.34 gram average. Okay, and then I'm going to say that 7 days ago, or on the 13th, I had a sample weight of 1.18 grams. Okay, so I can tell that they grew. I just don't know how fast they grew. All right, so the only thing I need to know here is how many days in the sample period, which in this case is 7 days. Okay, so there's that. So now let's just walk through this. Okay, so I have that. So I'm going to type in my W2, or my newest weight is, I'm going to punch this at 1.34 grams. Okay, and to get the natural log of that, I hit this button and it'll convert it. I know it doesn't make a whole lot of sense to you, but just stick with me here. Okay, and then we're going to subtract that weight, subtract this weight from the old weight, which is 1.18 grams, and I need to turn that into natural log. Okay, that, and then I hit equals. And I don't know if you noticed, but the formula, or what I typed in, was right above these numbers. It disappeared when I got the answer. Okay, so the difference in the natural logs is this number, which is basically 0.127, right? Still doesn't mean much to you. Okay, to get the daily specific growth rate now, I'm going to divide that by the number of days. Let me show you here the whole formula. Divide it by the number of days in the period. And then to get percent, I'm going to multiply by 100. Okay, so next thing I have to do is divide by 7, because it was 7 days in that period, right? Equals this number, which is, you don't really have to write these down, but I'm going to 0.018, and really 3 digits is enough, so I'm going to say 0.182. Okay, and then I multiply times 100 to get percentage, equals this. So my percent, my daily specific growth rate, is 1.82%. And what that means is each day, on average, starting 7 days ago, these things increased in weight by 1.8%. Okay, I'm going to leave it at that, and let's do another one. Okay, and let's do some smolts this time. Let's say it's winter time and you got some smolts and they're not growing very fast, but still you want to kind of keep track of things. So bigger number, doesn't matter. So let's go again with today's date. Let's just say I just weighed everybody at the hatchery today. So today's January 20th, and these fish weigh 11.2 grams. 11.2. Okay, I'm going to take the natural log of that, right? Okay, and then I'm going to subtract that and see how the formula is up here above the number, so you can kind of see how things are going. And my new weight, so I'm going to go 2 weeks. So that's 14 days ago. So on January 6th, I weighed them. and they were only 10.8 grams then. Okay, so and that's over a 14-day period, just so you know. Okay, so I'm going to type in 10.8 natural log of that. Okay, and see how this is all going up here. That equals this. I'm going to divide by what? I'm going to divide by 14 because I did this 2 days ago or 2 weeks ago. 14 equals, okay, and then to get percent I have to multiply by 100. Okay, so the percent is basically 0.26, I'm going to say 0.26%. So each day over 2 weeks on average they gain 0.26% of their body weight, which is not unusual in the wintertime. You don't get, depends on the water temperature, of course, and there are places that add artificial daylight to make the fish seem like it's springtime, and they might grow a little bit faster. But a wintertime growth over pre-smolts, fingerlings, and whatnot usually is not that great. Okay, so that is daily specific growth rate, a very, very important number. I'll get rid of this. Very important number to help you assess what your fish have done, and it could also be used then to help you look forward, which is another kind of another idea. But how are you going to know, like you're going to estimate like 2 weeks from now what do you think they're going to be? And of course there's a lot of things that could come into play. You know, if the water temperatures are on the rise, or the fish are going to be moved, or I don't know, you're going to change feeds or something. If daylight's increasing, that really has an impact on these fish. But at least you have some kind of something to base this on. So if they've been growing 0.26 and you're not changing anything at all, you might be able to project forward and say, okay, well, they're probably going to be 0.2, you know, I can just assume they're going to be 0.26 through the next couple of weeks or whatever, and then we'll check and see how they did. Okay, so an important number. And something I should have said in the beginning, but the key to this is getting really accurate sample weights, which is kind of another topic of discussion we'll talk about in class. But I kind of want to show you how this is just a little extra thing on daily specific growth rate. Okay, and kind of moving on now, thinking about that daily specific growth rate concept, and now let's talk about projecting growth. Really important for so many reasons. Not the least of which is what I had just said, where okay, well, they've grew this much here these last few weeks or the last month or whatever. How can I project forward? Because I got to make sure there's enough fish food for them. I kind of need to know what size they are. I might need to change the size of the fish food if they're gonna, be much larger, and they can move into a larger size pellet or particle. There's that. You might have a project that says I need to have these fish by such and such a size on such and such a date. Am I on track? Okay, and it's absolutely critical towards budgeting when you're budgeting for an entire year. Um, I used a lot of history, a lot of historical information to kind of show me what the trends were. But from that, you can make certain assumptions and go, okay, well, this week they're going to grow this much, and this week I'm going to guess they're going to grow this much, and there's a basis for that. But still, you have to be able to say this week they're going to weigh this much, next week they're going to weigh this much. Here's how much food I'm going to need to have on hand, and here's the sizes that I need. Really, really important. And again, this really goes back to getting accurate sample weights. I know it doesn't seem like such a simple process, but if you miscount or you weigh a bunch of water instead of fish, it throws all of this stuff out of whack. Okay, so we talked about looking backwards with the daily specific growth rate. Now let's think about projecting forwards. And I like this slide because it kind of shows like if you just wanted to do it by longhand, and I work with a guy who would never use a calculator. He did everything by longhand, which is lovely if you have the time. But basically, if you did it by longhand, you could type in, here's day 0, today's weight is they're 15 grams. The daily specific growth rate, not in percent here, is just as a decimal because it's a multiplier, is 0.022, which would be, if you move that decimal point over, it'd be 2.2%. Okay. So that's an assumption that this person has made. And so the daily gain at the end of today, they gained 0.33 grams, and all that was in multiplying this 0.022 times 15, and they got this much weight gain at the end of a day. Okay, so then we come down to the next day, and what would you do? You take the 15 plus the 0.33 that they gained, and you come up with 15.33 as a starting point. Okay, and these guys grow 2.2% by the end of but after 24 hours anyway, and they've gained more like 0.34 grams in that day. Okay, you take the 0.34, bring it out over here, add it to this, the previous day's amount, and here's our new starting weight for the next day, and on and on and on and on and on. And you could see how, if you were a professional scribe in the 1600s, this is the way you would do it. Not necessary today, even with just using our scientific calculator. So I'm going to show you how that works. So essentially the way this works is you can use the calculator, you can just do those repetitive multiplications for you, and there's a function key for that, and I'm not going to go into lots of detail, but if you can imagine this, you have your newest weight, or your answer. I want to know what the weight's going to be 2 weeks from now, is your old weight times 1 plus the daily specific growth rate. And you just need to think about that a little bit. Think about what you're doing. You're taking the current weight and you're adding this additional new weight. So to multiply that, so if you take, in this case, 15 grams, if you multiply it by 1, what do you get? You get 15. Okay, no weight change at all, right, for tomorrow. But that's not the way it was. It's 15 times 1.022, which takes the 15 and automatically adds that additional new weight. Okay, and I'll let you just kind of chew on that a little bit. And that's really all this is doing, this 1 plus dsgr, whatever that is, your daily specific growth rate, to the n, which means it's going to redo that multiplication for you over and over and over, just like that table I just showed you did. It keeps adding a new weight, taking the new weight, and then adding the next new weight, and blah blah blah. It just keeps going for as many times as you tell it to do. Okay, so in this case, your new weight, the one that you're trying to figure out, is equal 15 times 1 plus 0.022 equals, okay, this is to the end. All right, I'm messed up here. N equals the number of days in the project. And here, I'm sorry, up here, if you look up here a ways, you'll see that it's the 30 days is the assumption, which is how we come up with this number. But you understand the basic concept. Let's just go on and do this operation like we did the last time. Okay, and I'll make up my own, and we'll work through that. Okay, this x to the y is what you're looking for to do that new formula. And now I have to find my calculator here. Okay, I got that. So this x to the y right here is what I'm looking for. All right, that operation right there. And that says just take x and redo that operation y times, and y is the number of days you're going to be looking forward. Okay, so for this one, what we need is we need a starting weight, whatever that is. You need a start weight. Okay, you need to know what your daily specific growth rate, that's an assumption that you're going to make, and then n is going to equal the number of days that you want to project. Okay, that could be 1 day, or it could be 14, or it could be 30, much more than 30. I think you're, is it going to stay exactly the same? You kind of want to go with an assumption. How many days out you're looking is how many days out you think they're going to stay at that daily specific growth rate, because that's a pretty big assumption on your part, so you don't want to project out too far. Okay, so let's just try our own example. So in this case, let's do some chum salmon. Okay, let's say they are these 1.34 gram guys that I did before. So today's weight is 1.34 grams. Okay, so 1.34 And then what's your daily specific growth rate? Well, let's see. Before it was 1.82. Okay, right? Well, that's what we said. So let's go with that. So it's 1.82%. The decimal version of that, you move the decimal point over 2 points, is 0.0182. Okay, that's the multiplier. Okay, so each day, 0.0182. Okay, so I'm going to say times, so I want times 1.0182. Okay, and I have to have that 1 in there because I want to include today's weight plus the new weight. Okay, so that's what we're doing. Okay, and then x to the y, I just want to project 7 days ahead. Okay, I don't want to go too far. So I'm going to say x to the y is 7. Okay, equals. Okay, so the weight 7 days from now would be 1.52 grams. So today's weight, so they're going to grow from 1.34 grams today. 7 days, they're going to be at 1.52 grams. Okay, it's really very easy. Let's do it again. Let's do a different one. Oh, let's see here. Let's go with, we could go with our big guys that we had. Let's see, what did we have? We had, I want to say it was 11.2 grams. Okay, so we got our big guys here. We had some 11.2 gram guys. Let's type them in here. So 11.2 grams today times, and our daily specific growth rate on those guys before was looking at my notes here, was 0.26%. Okay, so 11.2 times 1 point. So let's see. 0.26% as a decimal. Got to add a couple of zeros in there. It's going to put you 0.0026. Okay, so it's going to be 1.0026. And then how far are we going to project? Let's go 14 days again. So 14. And see, this is typing it in here for you up here, what we actually typed in. So 2 weeks from now, they're going to grow from 11.2 to 11.6. Not a lot of growth, but 0.22% gain per day is not much. Okay, and that's over 14 days. All right, I'm going to leave that at that, and I hope you guys will practice these things together. I might actually give you some, maybe I should make up some numbers for you guys for next week, and that way you can see if you're correct or not. It's not exactly a quiz or anything, but if I don't give you some numbers with some correct answers, I don't know how you're going to find out if you're right or not. So let's just do that. But that's so that's daily specific growth rate, and also projecting growth. Okay, using some assumptions, using some quality data that you have. The projecting is super important, and it's something I really did a lot. So just a basic calculator, phone calculator probably will work fine. You can do it by hand if you really want to, and this is another operation that typically I let a spreadsheet do. But sometimes I was doing stuff on the fly. Sometimes I'd be at an office meeting somewhere, and I wouldn't have the computer at my disposal, and I could crank these things out pretty fast. So really good idea to be able to say, okay, well, I don't know if we can do that or not. If they're this size today and 14 days from now, and we want to grow them really fast, how are we going to be? Are we going to have enough pen space? Are we going to have enough fish food? What are we going to need to do? Really, really important, and again, critical for budgeting and project planning too. So really important information, and to reiterate, it goes back to good technique during the sample weight times. If you get a terrible sample weight that does not represent your group, or for some reason you made a mistake, it can have very costly effects across the board there. Okay, I want to go over one more calculation. This one's much simpler than the others, and this is called food conversion ratio, or FCR. Is what we call it. And basically, all it is how efficiently are your fish eating, okay? Or being fed, I should say. Lots of things can affect food conversion rate. And the basic line is the bottom line with food conversion rate is fish feed is very expensive, and it typically makes up the one half to one third of a hatchery budget. It's getting more expensive all the time. Much of fish food is made out of these bait fish that are caught off. Well, they're caught around the world, but it's this fish meal is getting outrageously expensive because it's so high demand around the world. And so, wasting feed in so many ways is a really terrible idea. So, it's a lot of it's a measure of the fish culture efficiency, but some of it also is a measure of how well the fish convert food. In wintertime, the fish just naturally go when daylight decreases, they can sense it. They're very sensitive to it. Actually, their bodies just kind of go into survival mode. It's like, well, these are going to be hard times, so we're going to kind of hang on to food and we don't need too much, and we're going to slow down our metabolism, and all kinds of things are going to happen. So a lot of different things. If you have a person who's just not paying attention at all to feeding, they just need to hurry up and get home, and the game's on TV, and they just want to hurry, and so fish are going to throw food in there as fast as they can. They're not really going to pay attention to the fish are eating, or not. A lot of the food's going to end up on the bottom, and it's going to reflect in the food conversion ratio. It could also tell you that you're just trying to feed the fish too much, and you need to back off. And here again, if you get a bad sample weight, it is going to throw things off. If last week the fish were really, really big and they grew really, really well, or so you thought, and then you did your projection and go, okay, well, I need to feed them this much food this week. Come to find out that last week's weight was off. It was way too big, and they didn't grow as fast as you thought, and you were overfeeding them all this week. And the fish cultures doesn't know enough to not feed if they're not eating, which is kind of basic, but oddly not common knowledge. Um, at least common practice, I should say. Then you're going to have some problems. So your food conversion ratio is a measure of efficiency, and the basic formula is very simple. It's the amount of food fed, as this last bullet says, amount of food fed divided by the total weight gain of that container of your group of fish, or the biomass. Okay. So in other words, if you look at the middle here, an FCR of 1 to 1, and it's a ratio, okay? 1 to 1 means that for every kilogram of feed that you fed to those fish, they put on a kilogram of weight. And we're talking about the biomass of the group, right? And maybe we should do a real quick, let me pull up that calculator again here real quick. Maybe we should do a real quick review of what biomass. And for this one, you don't have to have the scientific calculator, but since it's pulled up here, let's go ahead and do it. So on this one, let's say let's first, we have to know the biomass of the pond, and we have to know a couple things. So we have to know the old biomass and the newest biomass. Okay, we're going to subtract those two, and that's going to be our weight gain for a given period of time. Okay, so let's make up some numbers here. Let's say, and we'll make up some easy numbers. So there's 100,000 fish in a container. Okay, so let's punch that in. I got 100,000 fish. 1, 2, 3. 100,000 fish. Each one weighs, let's just say they weigh 2 grams. Okay, times 2 grams equals, so it's 200,000 grams, right? And everybody knows that there's 1,000 grams in a kilo, so let's convert this to kilograms. So let's divide that number by 1,000 equals, so there's 200 kilograms of fish to start with. Okay, and that was a couple of weeks ago. Okay, now here I'm not so worried about the amount of time. Okay, so 200 kilos of fish to start with. That's how many fish were in that tank. All right, so I come by 2 weeks later, and let's see. Let me use I could kind of make a guesstimate here. Let's say they put on, mm, let's see, six. So let's say they put on 2/10 of a gram. So let's say today there is, okay, see, I wrote down 200 kilograms. So let's go ahead and clear this. That's the old weight. And let's say today I weighed them, and now all of a sudden there's still 100,000 fish in there. Okay, nobody died. It's amazing. And let's say they weigh 2.2 grams today. Okay, they got a little bigger. Okay, so that equals that, and that's in grams. So let's divide by 1,000. So now I have 220 kilograms today. Biomass, right? Total weight of fish in the pond. Okay, so my difference is going to be today's biomass minus the old one, which was 200, equals that, 20 kilograms. So these fish put on 20 kilograms of weight. And I'm going to guess that it was 14 days ago. Okay. Okay, now the other number you have to have is how much food were they fed over that time. We know that they gained, there's 20 kilograms of weight gain. That's fine. But looking at the feed chart, which we are collecting on a daily basis, looks like they were fed about 30 kilograms of food. Okay, and I'm just making this number up. It's whatever. Another, again, proper record keeping. How much were the fish actually fed? Not how much were they scheduled to feed. How much was fed? Some days, some people might feed them more than what was scheduled, and sometimes you might feed them less. And we'll talk about that a little bit later. Feeds and feeding techniques later, but let's, for the sake of this argument, we're just trying to figure out food conversion rates. So they were fed 30 kilograms of feed, okay, and they put on 20 kilograms worth of weight. Okay, and actually number of days really doesn't matter. As long as you're keeping track, as long as it's all equal, as long as your sample weights, your new weight minus your old weight, is equal to the same amount of time that you have records for how much they were fed. Okay, it's pretty simple. All right, so let's clear this. So FCR is equal to food fed divided by weight gain. So food fed here was 30 kilograms, and the weight gain was 20 kilograms. Okay, so the food conversion ratio was 1.5 to 1. That's the way this works. Okay, let's do another one. We'll do one more. This time we'll use some bigger guys. So let's use our other guys here. And they were 11.2 and 10.8. So let's just say they were 11.2, and let's just say there was only 50,000 fish in this, like a circular pond or something. 50, 1, 2, 3. A shortcut is to just leave off these zeros, but I'm going to do it longhand here. So that equals this many grams. This is the newest weight, 560,000 grams. I'm going to divide by 1,000. So it's 560 kilograms of fish in this tank today. Okay. And then my old weight a couple weeks ago, doesn't matter, was 10.8 grams each. Multiply by, there's 50,000 fish still. Nobody died. It's a miracle. So they were 540,000 back in the old weight. Divide that by 1,000 to get kilograms. Okay, so 540 kilograms was the old weight. So they gained, remarkably, it's the same number as the other tank. I certainly didn't do that on purpose, but they gained 20 kilograms. That's their weight gain. Okay, now we're going to go look at the feed chart. And the feed chart says, I'm going to make up a number. Feed chart says they were fed 23 kilograms of feed over that whole period of time. Okay, So I'm going to take my 23 that was fed. Remember, here's FCR right here, food fed divided by weight gain equals this. So the FCR here equals 1.15 to 1. Okay? And that is that. So those are three super critical pieces of information for projecting feeds, measuring efficiency, kind of helping you keep on track. Are you meeting goals? Are you not meeting goals? Feeding too much food? Maybe we can cut back. Budget projections, all kinds of things. But those three things are super important. And I'll say it every time. It goes back to proper sampling, and we'll talk about that in class.